Hey guys, welcome to 4.4. This is probably one of my favorite lessons because this is where we talk about imaginary numbers. Yes, after this lesson you will finally be able to take the square root of a negative number. This is like the highlight of my year. I love this unit. Alright, so today we're going to talk about complex numbers. We're going to talk about I, which is your imaginary number. We're going to talk about adding and subtracting complex numbers, and we're going to do a little graphing at the end. You can go ahead and read the little history of imaginary numbers. You never know when there's a bonus question that may come up about imaginary numbers and maybe who came up with imaginary numbers. First thing we're going to cover is complex numbers. So a complex number can be written in the form of a plus bi. So a and b are real numbers, all the numbers that you can think of, including 0. So you are allowed to have 0 as within your complex number. So we wonder, all right, well, when do we need imaginary numbers? How do we come about into questions that involve imaginary numbers? And one of the things that you can think of is when you take the square root of a negative number. So let's go ahead and solve for x here. So we're going to subtract 2 from both sides of our equation because we're solving for x. So I have 2x squared equals negative 2. And I'm going to divide by 2. So we get x squared equals negative 1. Now, thinking back to inverse operations, how do we undo a squared? Good, take square root, so we're going to take square root of both sides. Now up until this point, you could just answer this question as no real solution, because up until now, we haven't been able to take the square root of a negative number. But now we can. So when you take the square root of x squared, thinking back to the last couple videos that you've watched, the square root of x squared is just x. And now what we know is that the square root of negative 1 is actually I. So we now can solve equations that involve taking the square root of a negative number. So something very important that you're going to want to walk away from with this question is that the square root of negative 1 is equal to I. So that's going to be very helpful throughout the rest of this lesson and throughout your rest of this unit. So now we can simplify all of these radicals that before we weren't able to. So thinking back to simplifying your square roots, you look at factors. So this time I would say, well, this is negative 1 times 16. We know 16 is a perfect square, so that would come out of our radical as a 4. We now know, though, that the square root of negative 1 is equal to I. So the square root of negative 16 actually turns out to be 4I. So anytime you're taking the square root of a negative number, your answer should have an I in it. All right, square root of negative 9. Well, square root of 9 is 3, and now that it's negative, you're going to have that I involved. So this just becomes 3I. All right, those were both perfect squares. C is not a perfect square, so let's break it down into all the factors. So we have negative 1 times 4 times 2. So there's all your factors of negative 8. Now we're going to go down and we're going to break down all of the perfect squares. So this is now an I. Square root of 4 is 2. 2 is not a perfect square, so that stays inside the radical. So this simplifies down into 2I times the square root of 2. All right, same rules apply when you have a number outside your radical. So we're just going to break this down. So we have negative 1 times 9 times 2. So the negative 1 comes out as I. The 9 comes out as a 3. So now you have a 3, a 4, and an I, all outside your radical. Multiply them all together, and then you're going to come up with 12I radical 2. All right? So all these times we haven't been able to take a square root of a negative number, we now can. All right. See if you guys are ready to try some on your own. So remember, we talked about, in the last lesson, you talked about simplifying your radicals, making sure that they had to have the same number inside the radical. But when you're dealing with negative radicals, you have to make sure that you take that I out first. So we're going to go through and simplify first before we add and subtract. So square root of negative 81 is 9i. Square root of negative 25 is just 5i. But I have to multiply that by the 3 that's already there. So this is going to become a 15i. And then the square root of negative 4 is 2i. So now all of our radicals are actually gone, and we're left with just imaginary numbers. Imaginary numbers are like terms, so you still have to follow all of your like term rules. So you are now going to combine all of these like terms. So if I take 9i, 15i, and 2i together, I'm going to come up with 26i, and that's going to be my final answer. All right, I'll do one more with you, and then I'll let you try C on your own. So I'm going to simplify negative 18. So this is going to be negative. Now, I know I'm now going to simplify this one more step, or take out one more step. I know that negative 9 is 3i. So I really don't have to write negative 1 times 9 times 2 anymore. I'm just going to pull that negative perfect square out. And we're going to subtract. I now know that this is negative 25 times 2. So this is going to come out as 5i. All right, so now I have 12i radical 2 minus 5i radical 2. So remember, you have to have the same number inside the radical in order to add or subtract, and you have to have like terms as coefficients of your radicals. So you have 12i minus 5i, so that's going to give me 7i. And then I'm going to put radical 2 at the end there. Okay? All right. Go ahead and pause your video and try letter C. All right, how'd you do? I am hoping that you came up with an answer of 16i radical 2. Okay, I went through, simplified each one, took out my imaginary numbers, combined all my like terms, ended up with 16i radical 2. All right, moving on to the next question here, you'll notice that now we're going to solve for x. So your same rules of solving apply. Nothing's changed there. So I'm going to isolate my x. So I'm going to start by subtracting 18. So that leaves me with 3x squared equals negative 12. Now I'm going to divide both sides by 3. And we now have x squared equals negative 4. So I'm really excited about this because now I can take the square root of a negative number. I know that the square root of negative 4 is 2i. Now let's go back to when you're solving and taking the square root. Watch what I'm going to put in front of my. So my answer is 2i. But remember, when you solve by taking the square root of something, you have to remember that your answer could be positive or negative. So we're going to add one more twist into this. So one thing that you want to do is when you're solving, remember to make your answer positive and negative. Okay, so don't forget that. When you're solving, you take the square root, go ahead and do plus or minus. Now, there's a nice little pattern that happens when you raise I to an exponent. So thinking back to all the rules we've talked about exponents, if you raise anything to the 0 power, it just turns out to be 1. So even I raised to the 0 power is just 1. Anything raised to the first power is just itself, so that's just I. Now, let's take a look at I squared, though. If I know that I is equal to the square root of negative 1. So if I'm going to multiply the square root, sorry about that, guys. If I'm going to multiply the square root of negative 1 times the square root of negative 1, I should just end up with negative 1. So I squared is equal to negative 1. Now that's going to come in really handy. So that little piece of information you're going to want to tuck away. Now, if I do I cubed, that means I really take I squared and I multiply it by I. Well, I know I squared is negative 1, and I know I is I, so this just ends up being negative I. Now, those are really the only 4 different values of I that you need to know, because there is a pattern that happens when you raise I to any power. It starts repeating. Anytime you have a multiple of 4, it's just going to simplify down to the same thing as I to the 0, which is really just 1. So this whole pattern just continues to repeat itself into a cycle. And all of your values of I are all going to simplify down to either 1, I, negative 1, or negative I. Okay, so there is a pattern that happens. So we notice that everything simplifies down into either 1I, negative 1, or negative I. And the only powers that your I will ever reduce to is either 0, 1, 2, or 3. Okay, after you start hitting multiples of 4, then it starts to repeat when you reduce it. So we've created what's called the wheel of I. So you're going to want to be able to recreate this. So memorize it. So as I create this wheel of I, you're going to want to make sure that you're able to memorize this. So around the outside of your wheel is the remainder. You'll see what I mean in just a minute about the remainder. And you know me and my spelling, guys. Sometimes I mess up. All right, remainder. So all around the outside is the remainder. So remember I told you it could either reduce to 0, 1, 2, or 3. On the inside is what it simplifies to. So remember I said it could simplify to 1, I, negative 1, or negative I. So inside is the simplification. So let's take a look. Remember, if you raised I to the 0 power, it just became 1. I to the first was just I. I squared is negative 1, and I to the third is negative I. So this wheel of I will help you simplify I raised to any power. So you will not need a calculator to simplify powers of I. So make sure you know this wheel. Make sure you can recreate this wheel, because it'll be a great tool for you to use. So if I wanted to raise I to the 51st power, it's going to either simplify into I to the 0, I to the first, I to the second, or I to the third. So what we do is, we said before, everything starts repeating after you hit multiples of 4. So you always divide by 4. So you say, all right, 4 goes into 51 how many times? All right, 4 goes into 5 once, that's 4, we subtract, bring down the 1, that's 11. 4 goes into 11 2 times, that's 8. 11 minus 8, we're at 3. Now here's the best part about this. We don't care how many times 4 went into 51. I don't care how many times 4 goes into the exponent at all. What I really am concerned about is the remainder. That is the important piece of information. Remember, your remainder will always be 0, 1, 2, or 3. In this case, it's 3. So I to the 51st is the same thing as I to the third. Okay, now I'm going to look back at my wheel of I. I go around to I to the third. That simplifies to negative I. So I know that I to the third is equal to negative I. That is the most simplified answer that you can give. Okay, let's look at 102. 4 goes into 102. All right, 4 goes into 10 twice. That's 8. Subtract that. That's 2. Bring down the 2. That's 22. And that goes in 5 times. Oh, sorry about that. It goes in 5 times. So that gives me 20 with a remainder of 2. Now remember, I don't care that went in 25 times. What I really care about is that my remainder is 2. So I to the 102nd power is really just the same thing as I squared. All right, I'm going to flip back to my wheel of I. I squared is equal to negative 1. Now, you will end up using I squared so many times that you will very quickly memorize that I squared is equal to negative 1. All right, pause your video. Go ahead and see if you can simplify I to the 76th. All right, how'd you do? Did you come up with an answer of 1? Okay, so anytime you come across I raised to any power, if it happens to be a multiple of 4, your answer is always going to come down to 1, because 4 is going to divide evenly into that multiple, giving you a remainder of 0 every time. All right, now we've added a little bit of a twist here. Just a number out in front. So all that means is you're going to simplify your I raised to whatever power, and then you're going to multiply that answer times whatever your coefficient is. So 4 is going to go into 17. Let's see, it goes in 4 times. That's 16. I have a remainder of 1. So I to the 17th is really equal to I to the 1st, which is really just equal to I. So I'm now going to multiply that times 7. So my final answer is just going to be 7I. All right, so you simplify that I term and then just multiply by the coefficient. All right, go ahead and try E and F, and then join me when you're ready. Okay, how'd you do? Notice I simplified I to the 315th, and that really just simplified down to negative I. But then I had to then multiply negative 4 times a negative I, which resulted in a positive answer for me. I recognized that I to the 32nd, that 32 was just a multiple of 4, so I knew that I wasn't going to have any remainder, and that was just going to simplify to 1. 2 times 1 is 2. All right, let's take a look at another question here. All right, now we're adding and subtracting here, so you're just going to go through, simplify each one very carefully and separately, and then you're going to combine your like terms. So I'll do A with you, and then I'm going to leave B for you to try on your own. So if I want to simplify I to the 51st, that's going to reduce down to I to the 3rd. So you can go ahead and do the multiplication, check, make sure I'm right. Okay. And then this is going to be minus 2 times this I to the 36th is just going to be, you're right, 1, because 36 is a multiple of 4. And then we have 4 times, let's see, I to the 19th is just going to simplify to I to the 3rd, which really is just negative I. But for right now, I'm going to leave this as I to the 3rd. All right, so I have an I to the 3rd on the left and an I to the 3rd on the right. So I'm now going to simplify those. So this is negative I minus 2. Now remember, this simplifies to negative I. So I'm multiplying 4 times negative I. This ends up being a negative 4I. I's act as like terms. They're just like your variables. So I can take negative I and I can combine it with a negative 4I. Remember, though, your A plus BI form. Okay, remember your A plus BI form. That's the form your complex numbers have to be in. So your number, your real number, has to come first. So negative 2 comes first, then negative 5I. So negative 2 minus 5I is your answer. All right, go ahead and pause your video. Do letter B. Simplify each one separately, okay? And then combine your like terms, and then come back to me when you're ready. All right, you should have ended up with negative 1 plus 8I. All right? So I went through, I simplified it. You see at the top, I did my original simplifying for all of my I terms, and then I went and took that wheel of I and transferred them all into the very simplest form. Went through, simplified everything, watching my positives, my negatives, combined my like terms, ended up with an answer of negative 1 plus 8I. All right, let's do a little graphing. These are pretty easy. If I want to graph negative 3 plus I, what I'm going to end up doing is I have to follow the real axis, which is just like your x, okay? And then I'm going to follow my imaginary axis, which is like my y-axis. So to graph negative 3 plus I would just go to the left 3 places, 1, 2, 3, there's my negative 3, and then up 1. So negative 3 plus I ends up being right there in my, remember this is the second quadrant there. And then if I want to do 2 minus 5i, I would go to the right 2 and then down 5. 1, 2, 3, 4, 5. And then my final answer ends up there. Okay, so the first one, A, landed over here, and B landed down there. All right, so graphing them is pretty easy. Okay. At this point, we're done with our video. Remember, there are no forms afterwards. You're going to come into class, practice your questions, and then when you're ready, you will take your check for understanding questions on your calculator. I look forward to seeing you guys in class.